Part 1 of your packet. So we've been talking about hypothesis tests, and we started our z-test, and we're just going to do a couple more examples for the z-test, and then we'll move on to our t-test. So a 1999 study looked at a large sample of students from a large southern university and reported that the mean cholesterol level among them is 168 with a standard deviation of 27. A more recent study at the university investigated a cohort of sedentary students. The mean total cholesterol among 71 students, n equals 71, was x bar equals 173.7. Is there evidence that the mean cholesterol level among sedentary students differs from the average among all the females? Okay. So let's assume that sigma equals 27. Okay, why would I make that assumption, that the population standard deviation is 27? That's the standard deviation for everyone, so the standard deviation for the sample should probably be fairly similar. At least we hope, since we are assuming that. Remember, it's usually not always great to make assumptions. We know what happens when we make assumptions. It'd probably be better if we'd taken a sample standard deviation, but in this case we didn't. So our best guess is that we're going to go with our population standard deviation is 27. Okay, so is there evidence that the mean cholesterol level among our sedentary female students differs from the average among all the females? Okay, so what was the average for all the females there? The average for all the females was 168. So the status quo or nothing interesting would be that the mean for the sedentary females is still 168. What would the alternative be? That the mean is, okay, did they come into this asking if it was less than or greater than, or already having something in their mind of which way they thought this would go? No, they just said different from, so I'm going to go with not equal to 168. What else do I need to do a hypothesis test? I know it's been a really long weekend, but if you look back at your notes, what else do we need? We need an alpha. If they don't tell me an alpha, I just need to pick an alpha. Okay. By default, we're going to choose 0.05. If you don't have a good reason to choose something else, 0.05 is a good safe choice. Okay, what else? I need to check my assumptions. Remember what the assumptions were. That we had a normal population or a sample size of at least 30. Okay, are one of those met here? My sample size is at least 30 since it is 71. What comes next? Yes, standardized to find our test statistic. That formula is x bar minus mu over sigma over the square root of n. Mu with the little O on it to remind myself that it's the value of the mean in my null hypothesis. So x bar is 173.7 minus my hypothesized mean of 168 over my population standard deviation, which I'm assuming is 27. Hopefully that's correct. Over the square root of n, and n is 71. Uh, 1.78? What next? I need my p-value. And remember, we said that the p-value is always going to be the area in the tail, that we're going to just remember as the area in the tail instead of trying to memorize formulas. Well, I got a positive 1.78. Okay, But what tail am I interested in? When you look at my alternative hypothesis is mu is not equal to 168. So which tail am I interested in? Both tails. So for both tails, what number would I put down here? Negative 1.78. Okay, and I want the area in both tails. My p-value is the area in both tails. Okay, which tail is going to be easier to look up on the z table? The negative value, since it gives us areas to the left. So if I look at my negative 1.78, it looks like we're at 0.0375. Everyone else check that. Everyone else should have a table in front of them so you can follow along with me. So this is 0.0375. And this area is 0.0375. So the probability, so 2 times the probability that z was greater than 1.78 is 2 times 0.0375, which gives me 0.075. So that is my p-value. Okay. Is that a big or a small p-value? It is, even though it's kind of a small number, it is still bigger than alpha. So 0.075 is bigger than alpha of 0.05. So we have a big p-value. This is my p-value, 0.075. So a big p-value, so will we reject or fail to reject the null hypothesis? Okay. So anytime we have a big p-value, we will fail to reject. Now, if I looked at this and if I had chosen alpha equals 0.10 to start with, because that is a valid choice, what would my conclusion have been? If alpha had been 0.10, we would have rejected it. So choosing your alpha could make a difference in your conclusion. Just to keep that in mind. So when we fail to reject something, this is how we prefer that you write your conclusion. As you remember, we said the statement that your boss is interested in is your boss is always interested in truly the alternative hypothesis. So even though we are describing our null hypothesis or testing our null hypothesis, what they're really interested in is, was the mean different from the average among all the females? That's really what he wants to know. So he wants to know, did you find evidence that the mean is different, or did you not find evidence that the mean is different? So in this case, what do you have? Okay, did we find evidence that it's different or not evidence that it's different? Okay. So you always start with the assumption that your null hypothesis is true. Okay. And then try and look for evidence to reject it and then kind of go for the alternative. But in this case, we failed to reject the null, so that means we don't have any evidence that this is false, and hence we don't have any evidence that this is true. So the way that we're actually going to write our conclusion when we fail to reject is that we didn't find any evidence, or we didn't find sufficient evidence, because we found some evidence at 0.075, we just didn't find enough evidence to conclude that the mean is different from .168. Okay. Notice here that I'm not saying that we found evidence that the mean is 168. We just didn't find enough evidence to conclude that it's not 168. Now, why do we write it like this? Okay. Now, you've all taken math classes. How many of you have taken a math class where you have to do a lot of proofs? Okay, a few of you. Can you ever prove something in mathematics by examples for it? Okay, no. you can disprove something instantly with one example that goes against it, but you can never prove anything with supporting examples. Even if you had a million supporting examples, you can't prove something with supporting examples. So it's kind of the same thought here, but where we don't say that really we have evidence that the mean is 168 or that we prove that the mean is 168. We were looking for evidence against it, and we just didn't find enough evidence against it. Okay. So again, this note that failing to find evidence against the null hypothesis only means that the data so far is consistent with the null hypothesis. Not that we have clear evidence that the null hypothesis is true. And a really good example of this thought of how you can't prove things with supporting examples is white swans and black swans. So up until, I forgot when it was, the 1600s, I think, everyone in England thought all the swans were white. Why? That's all they'd ever seen. So they thought all swans in the world were white. And then someone went to Australia, and what did they find? A black swan. And instantly that one black swan disproved their theory from thousands of years of supporting evidence that they were all white. So just keep in mind that if we didn't find evidence, all that means is we didn't find evidence. We haven't really shown that it's true, we just didn't find any evidence against it. Okay, so we've done a complete problem again over the weekend. Were there any questions on the process here? Let's try a few true or false problems. So the p-value of a statistical test is equal to the probability that the null hypothesis is true. True or false? You might have to look back in your previous pages to see what the definition of a p-value is. So flip back, see if you can find it. So the p-value is the probability of getting an outcome as extreme or more extreme than the actual observed outcome if the null hypothesis were true. So that means in our situation, the probability of getting a sample mean of, 173 or something more extreme further away from our expected value, if the mean really is 168, was only about 7%. Okay, so that's your definition. Now compare it to your true-false statement. The p-value is equal to the probability that the null hypothesis is true. So is that true or false? False. And I told you that this is a very common mistake, that people try and simplify the definition of p-value because it sounds complicated, and you can't simplify it. Okay, so for significance level alpha, if the p-value is smaller than alpha, we reject the null hypothesis.
False.
Why do you think that? Okay. Okay, so this is true. So if whenever we have a small p-value, so small p-value, we reject the null hypothesis. Okay. So for number 3, if the p-value is less than alpha, then the null hypothesis cannot be true. What are your thoughts on that one?
Too absolute.
It is too absolute. What was our conclusion when we rejected the null hypothesis? What did we say? We found evidence. We can't ever say like we proved it, but we did just find evidence. Okay? And part of this is, if you think back to the definition of the significance level, if alpha equals 0.05, then we say we'd only reject the null hypothesis in error 5% of the time. But you still have that 5% chance. So you haven't proven it. It can still be true, but it's only a 5% chance that it was true and you rejected it in error. An alpha percent chance of rejecting a true null hypothesis. And our last one, if our p-value is 0.1, you would reject the null hypothesis at significance level of alpha equals 0.05. So p-value is 0.10, alpha is 0.05. Should we reject or fail to reject? Should we fail to reject because that is a big p-value? So this was false and false. Questions on those? Okay. So our next example, example 7, an experimenter wants to test the null hypothesis that our mean is 20 versus the alternative hypothesis that our mean is not equal to 20. He takes a sample of n equals 40 measurements and he believes that the population standard deviation is 3.5. He wants to use alpha equals 0.01. For what z values, okay, that's your test statistic, so what values of your test statistic will he reject the null hypothesis? Notice in this setup, I haven't told you like what the actual sample mean was. I didn't tell you to go find a test statistic, and I didn't tell you to then find your p-value. We're kind of going to work backwards. So I actually just want you to tell me, so just kind of think creatively, for what z-values is he going to end up rejecting the null hypothesis? Okay, so this is a not equal to, so what tail are we going to be interested in? Both t-values, or both tails. Okay, so that could be like my negative z, and this could be my positive z. Okay, what area should I try and put in each tail? .005. Why? Half of 0.01. Okay, and the reason I need my 0.01 is alpha is 0.01. And so if we want to reject the null hypothesis, we need the area in the tails to be less than 0.01. So let's go back to our standard normal table, and we're looking for 0.005, or as close as we can get. Okay, what is that going to put us at? Okay, so it looks like we're evenly between that 0.051 and 0.049, so negative 2.575 is what I'm going to go with. So if I want to reject, I need to be in the tail, so I'll reject, reject. So I'll reject if what? Z is less than negative 2.575 or Z is greater than 2.575. So that is when you reject. Just remember, you reject when you're out in the tail, so you just needed to, in this situation, figure out where your tails would be to have your 0.01 area in the tails. So he knows in advance that he will reject if he gets z values less than negative 2.575 or greater than 2.575. Then for what z values will he accept or fail to reject the null hypothesis? You have to say it louder. Anything in between the two values. So from your negative 2.575 to 2.575. So fail to reject if Z is between 2.575 and 2.575.
Do we include that value on either side? Like, what if it equals exactly your alpha?
Okay, so I was hoping someone would ask that question. So if your z-value was right on the boundary, or let's say you got a p-value exactly equal to alpha. So let's say you got a p-value of 0.05 and alpha was 0.05. There's actually not necessarily like a controversy. I don't think anyone's fought over it per se, but there's a debate going on in statistics about what you should do if your p-value is exactly equal to alpha. Most of the time they say the probability of you ever getting a p-value exactly equal to alpha is so small that it almost never happen. There's complicated methods you can use if it happens. Some people say just flip a coin. Okay, so if you ever got a p-value exactly equal to alpha, just flip a coin to see if you reject it or not. Probably not the most mathematical way to do it. Okay? But like I said, the probability of that ever happening is so small that you don't have to worry about it. Like, it's never going to happen to you. Okay. So we've gotten this far. Now he conducts the experiment and finds a sample mean of x bar equals 19.3. So what is his conclusion going to be? So in this case, we've already figured out kind of this decision rule for what we'll do based on different z-values. So let's just figure out what his z-value would be. Okay, so he got our sample mean of 19.3 minus my hypothesized value of 20, and then 3.5 and 40. Okay, so my z-value here is negative 1.2649. Based on your rule up above, what are you going to do with that? Where does that z-value fall? In the fail to reject, because it's going to be right here. Okay, so we will fail to reject. Okay, so basically there's two different ways to do every hypothesis test. You can do what's called the critical value, where you do it like this, and ahead of time you set up your acceptance and rejection regions, or you can do the p-value method that we've been doing. For most of the class, we're going to just focus on the p-value method, because it's simpler and it's actually more accepted in practice. The critical value method was really only used when you had to use tables instead of computers. Okay, but occasionally in your book it will ask you questions like, for what z-values will you reject the null hypothesis? And so that's why we're going to try just a couple, just so you are kind of exposed to this. Okay, so we've done everything in that packet. Any questions?
Sorry, this is actually a question about 8.1 that we just turned in. Just a really quick question on homework.